take a look at our matter notes. Now, matter is something that takes up space. It has to have mass and it has to take up space. So things like heat and light are not matter because they don't have any mass and they do not take up any space. We're going to be talking about matter first because we're going to be getting into what the interior of the earth is made up of, and minerals and rocks, and started going into earth science, and to be able to understand how that matter is changed and moved and the energy that changes it and moves it, we need to understand what matter is made of. So that's why we're spending some time kind of reviewing some stuff that you might already know. So matter is something that has mass and it takes up space. If it doesn't have mass and take up space, things like heat and light, then it's not considered matter. Okay? Atoms are the building blocks of matter. Atoms are building blocks because our atoms is what comes together and it can be arranged in many, many different ways to form many different things, but they all are matter. So depending on the shape of the atom, how it comes together. So in this picture, you can notice that we have the same shape of atoms, and they're put together three distinctly different ways. And the way that those things are put together are going to give that piece of matter certain properties to it, certain physical properties, certain chemical properties, depending on how those atoms come together. So atoms are the building blocks of matter, and atoms can be arranged in many, many different ways. So the structure of matter, there are types of atoms in matter, and how they attach to each other or their arrangement is what gives it its properties. There can be two different types of properties to matter. Number one, it could be a physical property such as density, or it could be a chemical property such as its boiling point, that type of thing. So to understand matter, we must understand atoms and how they make up elements. So what makes up an atom? Well, first of all, let's go back here. Atoms are made up of protons, neutrons, and electrons. There's three basic particles that make them up. If you notice, the protons in this picture have a positive charge and they're in the nucleus, and the neutrons have no charge. The electrons are on the outside and they have a negative charge. So, protons and neutrons are located in the nucleus of the atom, which is the center part of the atom. Protons are the particles that have the positive charge, and neutrons have no charge at all. So that means that the center of the atom must have a plus charge to it. So, all atoms of the same element must have the same number of protons. So, for example, all iron atoms have 26 protons to them. That means that there are 26 protons in every single atom of iron that's found. And you can tell this number because it's our atomic number. It's the number at the top of the periodic table. And we'll take a look at that in just a minute. But it's the number at the top of the periodic table. We call that the atomic number. So whatever the atomic number is of an atom, that is the number of protons that are in there. This number can be found above the element symbol of the periodic table. I'm going to show you a picture of that in just a minute. Next is the electrons. Electrons are negatively charged, and they are not in the nucleus. They are outside, and they float around in these clouds, in these different layers of clouds that contain different energy and different amounts in each one. There's very little mass to electrons. The mass is so minuscule that we do not use the number of electrons to determine the mass of a atom. The number of electrons always equals the number of protons. So if I look at my atomic number, which is at the top above the symbol, it's going to give me my number of protons. That will also give me my number of electrons. So again, the three pieces are protons and neutrons. In the center, protons are positive, neutrons are neutral. Those make up the nucleus of the atom, which means it has to have a positive charge, the nucleus. Then we have an equal number of electrons that are floating around those clouds that are on the outside of the atom. And so if we have an equal number of electrons and an equal number of protons, then that atom has a neutral charge to it. So how many neutrons are there? Well, the mass number of the atom is equal to the number of protons plus the number of neutrons. That's our mass number. So to find the number of neutrons, I take my mass number, which is found at the bottom of the periodic table, minus my atomic number, and that will give me my number of neutrons. We're not going to worry about what an isotope is today. We will talk about that later. But I want to kind of go down and show you the periodic table right here, why we're talking about this. So in the center here is our oxygen. Oxygen, the number on the top, we said is our atomic number, correct? It's our atomic number. And the number at the bottom is our atomic mass, or our mass number. We take that bottom number minus the top number, and that will give us our number of neutrons. We will talk later on when we talk about isotopes about why that bottom number is not a nice even number. So that concludes the matter notes from slides 1 through 9.